Hi everyone, today we're going to be learning about how to divide polynomials. As we've talked about in previous videos, polynomials are just sets of big sets of chunks of numbers that have exponents and x's or variables. And so we've learned how to add and subtract them, we've learned how to multiply them, and now we're going to learn about how to divide them. There's a couple of different ways that you can divide these, and it kind of depends on what you're dividing by. And so I'm going to show you each way in the examples that are the most appropriate for them. So let's just start with the first example. The first example is 4x to the 5th power plus 16x to the 4th power plus 3x cubed divided by 8x cubed. So we're going to divide this whole chunk right here by 8x cubed. The way, when we look at this, when we're dividing like this, it's easiest to actually write it out so that it's like a fraction, because when we divide, it's really just a fraction form. So I'm going to put the 8x cubed right here instead of dividing it like this. And when we divide a big polynomial by only a monomial or a one chunk polynomial, that's the same thing as dividing each separate portion or each separate term of the top polynomial by the 8x cubed. So I can rewrite this as 4x to the 5th over 8x cubed plus 16x to the 4th over 8x cubed plus 3x to the 3rd over 8x cubed. And what we're going to do is simplify each chunk individually. So when we simplify each chunk, the first thing I'm going to do is simplify the numbers that are in front of the x's. And so on my first fraction, we have 4 and 8. When I simplify 4 and 8, those are both divisible by 4, which means I can divide both of them by 4, which would give me 1 over 2. Great. Now we look at the x's. So on the top, we have x to the 5th, which really says that we have 5 x's. And I could write them out like 5 different x's. And then on the bottom, we have x to the 3rd, which means we have 3 x's. And so if I have 5 x's on top, in fact, I'm going to kind of write it out like this. If I have 5 x's on top, like this, and 3 x's on bottom, what we can do is simplify by canceling out an x on the top and an x on the bottom. So I've got this x right here and this x right here. Those ones cancel each other out. These guys cancel each other out, and these guys cancel each other out. Now there's no more x's on the bottom to cancel out, so we're kind of done. We can't simplify anymore, but we are left with 2 x's on top, which means that my answer would have an x squared on the top. So this 1x squared over 2 is my simplified version of the first fraction. Now the second fraction, we have 16x to the 4th over 8x cubed. We're going to start with our numbers in front, our coefficients, which are 16 over 8. 16 divided by 8 gives me 2. So I can write it with just a 2 up top. When it gives me a whole number, we put that whole number on top of the fraction. And then we have x to the 4th on top and x to the 3rd on bottom. We could do it the same way we just did with like writing out 4 x's on top and 3 x's on bottom. But another way we can do is actually just subtract the exponents from each other. So 4 minus 3 gives me 1, which means I'm going to have x to the 1 on top. And whichever exponent is higher, that's where your answer is going to end up. So because that 4 is bigger than 3, and 4 is the exponent of 4 is on the top of the fraction, my answer will end up on the top of the fraction. So there's nothing on the bottom. We can leave it like this. I could erase that part. Doesn't really matter. And then for the third fraction, we have 3x cubed over 8x cubed. So the 3 and the 8 won't simplify each other. There's nothing that they have in common, so we just leave it as 3 over 8. And then for the x's, we have x cubed on top and x cubed on bottom. Now, if we wrote them out like we did on the first fraction, there'd be 3 x's on top, 3 x's on bottom, and they'd actually all cancel each other out, which means that we just don't have any x's left. And this is our final answer. Okay, cool. Let's do another example kind of like that, which is number 2. And that one says 36x cubed plus 9x squared plus 45x, all divided by 9x squared. So on this one, once again, we're going to write it in a way that it makes it look more like a fraction. So I'm going to put the 9x squared on the bottom, and we'll just erase this part. Okay, so when we divide a polynomial by a monomial, we can divide each section of the polynomial by that monomial. So I can rewrite it as 36x cubed over 9x squared plus 9x squared over 9x squared plus 45x over 9x squared. And now we're going to simplify them each individually. And so we would get, we start with the first fraction. So 36 divided by 9 gives me 4. Because it's a whole number, it just ends up on the top of the fraction. And then for our x's, we have x cubed over x squared. So we have 3x's over 2x's. To simplify that, we're going to do 3 minus 2, which gives me 1. So I'm going to have just x to the first power, or I can just write 4x right there. And because it ends up, there's nothing on the bottom, we can get rid of the fraction sign. Then we're going to move to the second fraction. And on the second fraction, we're going to have 9x squared over 9x squared. And those literally say the same thing on top and on bottom, right? So when they say the exact same thing, what happens is they get canceled out. And so we are just left with a 1. So I can say plus 1. And then for the third fraction, we have 45x over 9x squared. We're going to start with the 45 and the 9. So 45 divided by 9 gives me 5. I'm going to put a 5 on the top of the fraction because it was a whole number. And then for the x's, you have just a regular 1x on the top, and then on the bottom you have x squared. So that's the same thing as like saying, okay, I've got 1x up top and then 2x's on bottom. So I can cancel out 1x on top with 1x on the bottom, but we're left with 1 extra x on the bottom, which means that my answer would have an x on the bottom. And this is actually our answer. So 4x plus 1 plus 5 over x. And there we have it. Okay, so that is one way to simplify or to divide polynomials. The other way is with when you're dividing a polynomial by a binomial or something with 2 chunks. And that's what we're going to talk about in the next 2 examples. So for the third example, we have x squared minus 3x minus 28 divided by x minus 7. Now there's 2 different ways that we can do this. One way is with what's called synthetic division, and the other way is with what's called long division. And synthetic division tends to be easier, so we're going to use synthetic division in this case. Next year you'll learn about both of the different ways that you can use them, like the long and synthetic, but for this year we can just use the easier version. So when we use synthetic division, what we're going to do is take the thing you're dividing by, which is x minus 7, and set it equal to 0, and solve for x. So to solve this for x, I'm going to add 7 to both sides to get x by itself, which would cancel the 7's out right here, and we'd just be left with x is equal to 0 plus 7 is 7. So I know that x is equal to 7. Now that's not necessarily my answer, right? That would be way too easy. But what we're going to do is now put that answer on the outside of a box. And on the inside of the box, we're going to put the coefficients of the numbers that we're of the polynomial we're dividing. So this x squared minus 3x minus 28. Now, when I say the coefficients, I mean the numbers in front of the x's. And we need 3 because you have 3 chunks to this polynomial, so you need to have 3 numbers to represent it. Now, this x squared in front doesn't have a number in front, but when it doesn't have a number in front, there's a 1. And so we're going to put 1, and then -3, and -28. Those are all of the coefficients or the numbers in front of our x's. You need to make sure that you keep the signs with them. So this right here is just the setup, and that's half the battle. Now we can actually divide. So to divide, what we're going to do is we're going to drop the first number. Always drop the first number. Then from there, I'm going to do the first number, that number that I just dropped, the 1, times the number on the outside of the box, which is 7. So 1 times 7 gives me 7. Then I write that under the next number. So now I have these 2 numbers, -3 and 7, and I'm going to add them together, which would give me 4. then I start the whole process over. So now I'm going to do 4 times the number on the outside of the box. So 4 times 7 is 28. I put the 28 over here under the next number, which happens to be negative 28. Then I add those two things together. So negative 28 plus 28 gives me 0. So I'm all done because there's no extra numbers left. And we're actually going to now write them back with x's. And what happened, when we divide polynomials, we're essentially taking an x out of the polynomial. So in this first polynomial that I started with right here, my highest exponent was squared, or x squared. And so when I divided that, I'm taking an x out of it, which means that what I'm going to do with my answers down here is I'm going to say 1x plus 4. Excuse me. The reason why I just do it with an x is because my highest exponent in the original function was x squared, but I'm taking an x out when I divide, and so when I divide, I end up with just 1x. And then the next number, just kind of like on this polynomial, how you go from x squared to x to something without an x, your answer has to do the same. So because I started with just an x, my second number would have no x. Now, this number at the very back will always be what's called your remainder. And if you do it right, particularly for this self-check, you should always have zeros for your remainders. So this 1x plus 4 is my final answer. Okay, and now let's just do another one similar to that. So, excuse me. Let's do the fourth example. And the fourth example is 4k cubed minus 17k squared minus 43k plus 6 divided by k minus 6. So we're going to do it exactly the same way as we did that third example. The first thing we're going to do is take the thing we're dividing by, which is the k minus 6, and set it equal to 0 and solve for k. So to solve this for k, I'm going to add 6 to both sides, which would give me that k is equal to 6 because these 6's over here cancel out. Now that I know k is equal to 6, I'm going to put the 6 out here on the outside of this box. And then on the inside of the box, we're going to put the coefficients of the thing we're actually dividing by, which is this right here. So I would have 4 for the k cubed, negative 17 for the k squared, negative 43 for the k, and 6 for the constant term. So this is my setup. Now we're actually going to go through and divide. To divide, we drop the first number always, and then we're going to do the number on the bottom. So 4 times the number on the outside, 6. 4 times 6 gives me 24. Then I add those together, and I get 7, and I put the 7 down below the line. Then we're going to do 7 times the number on the outside of the box. So 7 times 6 gives me 42. Then I add those, the negative 43 and the 42 together, and I get negative 1. And then we do negative 1 times the number on the outside, which gives me negative 6. I add the 6 and the negative 6 together, and I get 0. And the thing that's below the line is my answer. And remember, the number on the back should be my remainder, which again is 0. So now I just have to take my answer, the 4, 7, negative 1, and put my x's, or my k's in this case, back into it. To put my k's back into it, my original polynomial started with k to the third as my highest exponent, so my answer will start with k squared as my highest exponent. So I'm going to have 4k squared plus 7k minus 1. Notice on this one I had to drop a k and then drop a k again because you started with squared, but you can't just take both of those k's away. You have to keep on taking one away at a time. So you had k squared, then k, then something without a k. And this is my final answer. And this is how we divide polynomials.